We just deal with the formula here. I hope you get a chance to practice all these formulas. This is the basic one, okay? And we show how to get to this result, okay? We show how to get this result. And now you want to practice on your own how to get this result, and also how to get this result. As you may know, constant practice makes perfect, okay? So you want to practice as often as you can. Okay, any questions? Now we get to a numerical example. Let us finish this first, okay? Let us finish this first. We say if x, y are independent, then the covariance will be equal to 0, right? And we also know if px times py is equal to px and y, we know they are independent too. So now you have two ways to verify if two variables are independent. One way is this. One way is this. But you have to be very careful here. If x and y are independent, then covariance x and y is equal to 0. But if covariance x and y is equal to 0, x and y are not necessarily independent. Okay? Why? Why is the case? So we say if x and y are independent, then the covariance will be equal to 0. And if the covariance is equal to 0, x and y are not necessarily independent because, as you know, covariance of x, y is equal to expectation x minus mu x and y minus mu y. This is a linear relationship, okay? This is a linear relationship. Linear is about line, okay? Linear relationship. So, as a matter of fact, covariance of x, y only defines the linear relationship between x and y. But as you may know, independence, okay, it has various aspects. It has more than one aspect. And covariance only deal with linear. And this one may deal with something other than linear. So because covariance only deal with linear relationships, so if it is equal to 0, you can only say x and y are independent when the relationship is linear, okay? So you have to remember this. Now let's get to a numerical example about two random variables. Okay, let me erase this. So again, cast a coin twice. Okay? So x is equal to number of heads. Okay? And y, if the second time is head, then y equals to 2. The same thing if the second time is tail, then y is equal to 1. Okay? So we have two random variables. One is x, the number of heads. The second one is y. If the second time you see head, then y is equal to 2. If the second time you see tail, then y is equal to 1. Okay, so this is very clear. So let us now get to the distribution of x and y. Okay. So because we know we cast a coin twice, we have 4 results. We have 4 different outcomes. So H, 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 T, TH, and TT. Okay? Heads and tail. How much it should be here for X? It should be equal to your response doesn't have to be in English. How much should be here? Should be 2, right? And how much it should be Y? Because there are 2 heads. Okay, there are 2 heads. So X must be equal to 2. For Y, you have to look at the second one, right? The second one, what is this? It is H. So how much it should be here? It should be 2, right? And here, in this case, how much it should be X? It should be equal to 1. Okay? And how much it should be here? It is tail, right? If it is tail, it is equal to 1. If it is head, it is equal to 2. It is tail, 1. And here, you have 0. Okay? So now let's get to the distribution table. So X and Y, right? X has 3 possibilities, okay? One is 2, 1, and 0. And for Y, that will be 2 and 1. What's the chance that X is equal to 2 and Y also equal to 2? It is here, right? 2, 2, okay? So that would be 1/4, okay? What is the chance that X is equal to 2 and Y is equal to 1? X is equal to 2 and Y is equal to 1. What's the possibility? What's the probability here? Is there anything here? No, right? There's nothing here. Nothing with X is equal to 2 and Y equal to 1. So it should be 0, okay? And now we have X is equal to 1 and Y equal to 2. So X, 1, Y, 2. You have only one outcome, right? So 1/4. X equal to 1 and Y equal to 1. Okay? X, 1, Y, 1. Okay? 1/4. X, 0, Y equal to 2. 0, right? And X equal to 0, Y equals to 1. One possibility, right? So that's 1/4. So any questions so far? How to draw this picture? Okay, this diagram, okay, this table. You have to match all the numbers. Say X, 2, 1, 0, right? And Y, 2, and 1. In this case, you know. What's the probability that this is going to happen? The probability that this will happen is equal to 1/4. That's 1/4. 0.25, right? 0.25. The same thing, the same thing, the same thing. So that's the reason I can put here. That's 0.25, right? 0.25. It says 1/4. Okay, so when you get this result, it should be easy for you to put down this table, okay? Because you just match 2, 2, it is here, right? 1/4. 2, 1. X equal to 2 and Y equal to 1. Is there anything here? No, you cannot find it. So it should be 0, okay? So in this case, you know. In this table, we know this is 1/2, 1/2, and this is 1/4, 1/2, 1/4. So that's exactly the same as we have done before. Because in this case, Px is equal to 2 is equal to 1/4. Px equal to 1 is 1/2. Px equal to 0, 1/4. And Px equals to 2, sorry, it should be Y, okay? Y equals to 2 is equal to 1/2. Py equals 1 is equal to 1/2. Okay? Any questions so far? Of course, we have done this before. We know expectation of x is equal to 1, expectation of what, variance of x is equal to 1/2, right? Okay, you want to practice to verify the answers. And now, let us try the expectation of y, okay? So, what is expectation of y? Expectation of y is equal to summation y times py, right? So in this case, the first one is 2. And what's this rho? This rho is marginal probability, right? We talk about marginal probability because these probability are on the margin, the same thing, marginal probability. And let us get to this. It should be first one 2 times 1/2, right? Plus 1 times 1/2. Okay, so what do you get? You get 1.5. Okay, and now let us get to variance of y. Okay, variance of y. Variance of y is equal to summation, okay, y minus mu y squared times py, right? Okay, so you know this is 1/2. 1.5, so 1.5. The first one is 2. 2 minus 1.5 squared times 1/2 plus the second one is 1 minus 1.5 squared times 1/2. Okay? Any questions? So this is equal to 1/4 times 1/2 plus 1/4 times 1/2. Because 2 minus 1.5, what do you get? You get 1/2, 1/2, right? So this is 1/2. 1/2 squared will be equal to 1/4. 1/4 times 1/2, and this is the same thing, right? This is equal to 1/2. That is 1/2. 1/2 squared, you get 1/4. So in this case, what do you get? You get 1/4. But of course, these are just some of the practices of the formula we learned before. Now we want to get to the new formula, okay? We want to figure out what's the relationship between these two, okay? So the first question, are x, y independent? Are these two variables independent? Are these two variables independent? So there's one way to verify, right? So let us say px times py, okay? If it is equal to px and y, then they are independent, right? So let's randomly choose a number. Say px is equal to 2 times py is equal to 1. If this is equal to px equal to 2 and y equals to 1. If this side is equal to this side, then we say they are independent, right? So can anyone tell me how much is px equal to 2? How much is here? Here, right? Okay. 1/4. And how much is here? You look at here, right? So that's 1/2. Okay? So this is equal to 1/8. And what about here? Here is x is equal to 2 and y is equal to 1. So what should be the number? The number is here, right? So it is equal to 0. So are they equal to each other? No. So are x, y independent? No, they are not independent. Okay. So first one, all these questions are quite common, okay, very common. So you want to know how to deal with the relationship independent. And now let us calculate covariance. Okay, so let me erase this part. We want to deal with covariance of x and y. Any question on this? Any questions on this? So we say covariance of x, y is actually equal to expectation x minus mu x, y minus mu y, okay? And we know there's a way to simplify it, right? How to simplify it? Expectation x, y minus mu x, mu y. Okay, the difficult part will be to calculate this, okay? But because we have formula, you know the definition. So let's put down the definition. Definition of expectation of x, y should be equal to what? Summation x, y times p, x, and y. Okay, what does this mean? We will get to it, okay? So the first one is x is equal to 2 and y is equal to 2, right? But what's the probability? The probability here, because in the past, we only deal with one variable, right? So then here will be px or py. But in this case, we are dealing with two variables. So we have to take care of two variables. So in this case, x and y, right? X times y. So when x is equal to 2, and here when y is equal to 2, what should be the probability here? The probability here should be px is equal to 2 and y is equal to 2. Okay? So that's the difference. When we have only one variable, right? So you have expectation x is equal to summation x times px. That's easy. But now we have two variables. So you have x and y. So you have to get this one is when x is equal to 2, and this one is when y is equal to 2. So the probability should be here, because this is when x is equal to 2 and y is equal to 2. So it will be 2 times 2 times 1/4, okay? The second one will be 2 and 1, right? So here you would have 2 times 1 times 0, okay? And the third one, 1 times 2 times 1/4, okay? And the third one is 1 times 1 times 1/4, okay? 1, 1, 1/4. And then here it is 0, right? 0 times 2 times 0. Okay, 0 times 2 times 0. And then 0 times 1 times 1/4. So the same thing, the same formula, just a different way to plug in the numbers, okay? Here is the random variable, and here is the probability, okay? So what do you get? You get here is equal to 1, 0, and here is 1/2, okay? Here is equal to 1/4, and here is 0 and 0. So what do you get? You get 7/4, okay? 7/4. So what does that mean? What's the relationship between x and y? They are positively related or negatively related? They are positively related, okay? They are positively related. Okay, any questions? So let us continue on the two variables, okay? We can now say something more about the distribution, probability distribution of two random variables. Is it clear here? But of course, I seem to mistake something because what is here? Here is only this part, okay? Here is only this part. We have to get to the second part, right? So I haven't done this. So in this case, this part is equal to 7/4, and this part is equal to 1 times 1.5, right? So that would be 4/7 minus 4/6, okay? I mean 7/4 and minus 6/4, okay? So that would be 1/4, okay? That would be 1/4. So we can conclude there is a positive relationship between x and y, okay? Because this number is positive, okay? This is a positive number, so x, y are positively related. But how closely are they related? So if we want to figure out how close their relationship is, then we have to use rho xy, right? Rho xy is equal to covariance xy divided by sigma x, sigma y. Okay, so we know this is 1/4 and divided by this, right? Square root of 1/2, and this one square root of 1/4, okay? So in this case, so this is what we have, right? And this one can cancel out with that one, so that is equal to square root of 2 over 2. So that would be 0.7 something, okay? About 0.7, okay? So what does that mean? They are very closely related, okay? They are very closely related. Any questions? So basically, when you get to midterm, you need to know mean and expectation and know how to calculate it. Whatever data I give you or whatever probability function I give you, you should be able to calculate the mean, the expectation, the variance, the standard deviation. And also, if I give you two variables, then you should be able to figure out what's the relationship between them. So that means you have to be able to calculate covariance and correlation of coefficient, correlation coefficient. Any questions? Okay, because now we talk about two variables, so we know if we have only px, it will be between 0 and 1, and summation of px is equal to 1. But now we have two variables, so let us say we use f, x and y. The same thing, it has to be between 0 and 1. But now, as you know, we have two variables, right? We have two variables. So it will be summation x and y. fx y is equal to 1. Okay? Because we have two variables. So now, how should we deal with all this? Because we have two variables, right? We have two variables. Oftentimes, we deal with one variable at a time. When we deal with one variable, the other variable will be treated as constant. So for example, if we add from the y side first, okay, we add the probability from the y side first. So what do you get here? You get summation x, and this part is actually fx. Of course, this is probability function, okay? This is a probability function. If we have add up all the probability from the x side, from the x variable, what is that? That would be equal to 1. Okay, the same thing. If we have summation yx, fxy is equal to 1. Because now you add from the x side first, okay? We add from the x side first. So what do you get? Summation y fy is equal to 1. So in either case, this is what you get. So now let us try to figure all these out from the example we just talked about. We have x, okay? We have y. This is 2, this is 1, 2, 1, 0. You have 1, half, 0, 1 quarter, 1 quarter, 0, 1 quarter. You know, as a matter of fact, this row, okay, this row is fy, right? And this column is fx, okay? So this is equal to 1 fourth, 1 half, 1 fourth, 1 half, 1 half. So what does this mean? If we want to know fx, okay? If we want to know fx, that means we want to know here. Okay, we want to know here, here, here. We want to know the number here. We want to know fx. If you want to know fx is equal to 2, you need to know when x is equal to 2 and y is equal to 1 and y is equal to 2 and y is equal to 1. Add them together, what do you get? You get fx. Okay, so this is exactly here. If you want to know fx, you need to know to add from the y side. If you want to know x, okay, you need to know the y side. Okay? The same thing, if you want to know x is equal to 1, you have to add from the y side. You need to know when y is equal to 2 and x is equal to 1 and y is equal to 1 and x is equal to 2. The same thing, if you want to know the y side, okay, you need to know the x side, because here you want to know the number here, right? But you need to know when x is equal to 2, x is equal to 1, x is equal to 0, what's the probability here? So this is an example to show you, if you want to know y, you have to know x side first. If you want to know y side, okay, x side, you have to know y side first. Okay, sounds quite confused. Anyway, you want to do some examples, okay? The books has some examples. Okay, let's continue. The same thing, right? Because sometimes you may know y first. Sometimes you may know x first. And in this case, if you know y first, then you may have some information, right? And in this case, so we will deal with conditional probability, okay? Okay, the same thing. You have when y already happened, okay, when y already happened, then what's the probability that x is going to happen, okay? When y already happened, then what's the probability that x is going to happen? The same thing, because y already happened, right? So we are looking at fy, okay, instead of the whole sample space, because we already know y happens. And of course, y happens and also x happens. So that would be here, fxy. So now let us get to one example. Say, I want to know what's the chance that x is equal to 2 when y is equal to 1, right? So then you need to know fy is equal to 1 and fx is equal to 2 and y is equal to 1, right? So when you know, what does y is equal to 1 mean? We say y is equal to 1 when the second time it shows tails, right? We say y is equal to 1 when the second time shows tail. So then, in this case, you already know the second one is a tail, right? The second one is a tail. Then what about the first one? X is equal to 2 means the first time has to be head. Also, the second time has to be head too. You need to have 2 heads, right? But you already know the second one is a tail. Can this one happen? No, right? Remember, I'm just trying to refresh your mind. What means y? Y is the second time, y is 2, then that means, so this is the first time, this is the second time, right? First time, second time. Y is equal to 2 means it is head. When y is equal to 1, it is a tail, right? But x is equal to 2, what does this mean? Both of them has to be heads, okay? Both of them has to be heads. You already know the second one is a tail. Can this one happen? No, right? So the conditional probability will be equal to 0, okay? Okay, so basically that's the same thing, but we just use a different way to deal with it. The first one, we talk about 2 events, okay? 2 events, A something happened, then B the other thing. Oh, this is a male, right? And what's the probability that he is a high, junior, freshman, senior, whatever. And this is the same thing. Okay? Any questions? Okay. And also we have conditional probability, right? So we have conditional mean. Conditional mean. And also conditional variance. Okay? What are all these? Remember when we say expectation, we have this is equal to summation x times px, right? We have variance, we have summation x minus mu x squared times px. Okay? But now we are talking about conditional mean. What does this mean? Expectation of x given y. Okay? Expectation of x given y. So when we calculate mean, okay, we have x times px. But now we are going to calculate conditional mean. The mean of x given y happen. So what should be the probability we use? We should use summation x times px given y. And what is this? It will be summation x times py and then here pxy. So basically it's the same thing, okay? Basically it's the same thing. But of course you know, here you use probability of x, right? But here what do you use? You use conditional probability, okay? And the same thing, vx given y, okay? You have summation x minus mu x squared times px over y. I mean x given y. And you have summation x minus mu x squared times py over pxy. Okay? And then there's one more thing you need to be careful about. If x and y are independent, then expectation of x given y is equal to expectation x. Variance of x given y is equal to variance x. Okay? Why? The reason is if x, y are independent, then we know px times py is equal to pxy, right? Or we say p and y, whatever it is, pxy. And so what does that mean? That means px will be equal to pxy and then py, right? Because we say if we want to calculate the mean of expectation x, the mean of x given y, then it's equal to this part, right? And now if we know further that x and y are independent, so that means this is true. Okay, this is true. If this is true, then pxy divided by py is equal to x, right? So that means this part is equal to px, exactly here, right? Exactly here. So then you know, if x and y are independent, that means x does not affect y, or y does not affect x. So then in this case, the conditional mean, okay, the conditional mean will be equal to the mean itself. And the conditional variance will be equal to the variance itself. So any questions? Any questions so far? Okay, let's take a break. And page 77, you get geometric mean, okay? Geometric mean. And also in one example, we talk about not the growth rate, but the rate of return, okay? The rate of return. How to calculate the rate of return? If you look at page 78, that is exactly the way to do it, okay? And then you talk about group data. We just forget about that part, okay? And then you get to page 88. Page 88. So we say there are distributions like skew to the right, okay, and skew to the left, right? And what's the relationship between mode, median, and mean in each case, right? We talked about this before. Page 88. Okay, page 88. You look at if it is skewed to the right, okay, if it's skewed to the right, then mode is less than median and is less than mean, okay? And if it is skewed to the left, that would be the other way around, okay? Okay, in this case, you want to do some exercises here because mean, okay, there's a formula for mean. You want to know how to use that formula, okay? So now we get to chapter 4, page 100. This is about dispersion, right? So how widespread is the data, okay? How widespread is the data? So we have range, right? Also we have quartile range. Quartile range, okay? And then we talk about mean deviation, right? Mean deviation. So you need to have absolute value, okay? You need to have absolute value so that you measure the distance of each point, how far away is each point from the mean, okay, from. And of course, you're going to get to variance, okay? Page 104, variance, okay? We also talk about today the variance of a random variable, okay? And also, there's a difference between population and sample. So if you look at page 104, that is for population. And if you look at page 106, that is for sample, okay, for sample. Okay, any questions so far? So far, so good. Okay. And of course, we talk about, two types of data, okay, two types of data. And you want to know what's the difference between those data. Which one is more dispersed than the other? Then we have to get to coefficient of variation. That is 115. Turn to page 115. 115, it talk about, if you want to know the difference between two types of data or distribution, then you can use this coefficient of variation. And skewness, that is 117, because in this class we don't want to talk about all this, so you can forget about this part, okay? You can forget about this part. Of course, there are other measures of dispersion, okay? But, in this case, you don't have to worry about it, okay? You don't have to worry about it. So, basically, we have done chapter 1 to chapter 4 is all done, right? You have to do some exercise there, and then get to the probability concept. That's the last part. We just finished 2 hours ago, right? Probability, okay? And we talk about experiment, we talk about outcomes, events, sample space, okay? Turn to page 153. 153 talk about some background stories, okay? What's classical probability, and what's mutually exclusive, collectively exhaustive, all these ideas. Basically, what we use is on page 155. We use empirical concept, right? Empirical concept, and that's relative frequency, okay? We use relative frequency. So, turn to page 158. That's rules of addition, right? So let us say we are interested in, let us say the experiment is cast a dice once, okay? Cast a dice once. What's the probability? How many outcomes there? It will be 1, 2, 3, 4, 5, 6, right? And we are interested, what's the probability 1 or 2 will happen? So what does this mean? What would be the probability? It is probability 1, okay, x is equal to 1, or x is equal to 2. And how to get this number? So that would be the probability of x is equal to 1 is 1/6, right? And the probability of x is equal to 2 is equal to 1/6. So the probability of 1 or 2 going to happen, it is 1/6 plus 1/6, and that's equal to 1/3, right? Do you follow me? Yes? Okay, so I should put that down. Okay, thank you for your feedback. So, cast a dice once. Okay, we have 6 possibilities. 1, 2, 3, 4, 5, 6. And now I say I'm interested in Px is equal to 1 or Px is equal to 2, right? If I say P is equal to 1, that would be very simple, just 1/6. The same thing, Px is equal to 2, that will be equal to 1/6, right? And you know, these two has no intersection, right? And you know, if I say I'm interested in this happen or this happen, okay, so that is P, let us say this is A, right, and this is B. A or B, that would be A union B, right? And so that would be 1/6 plus 1/6, so that would be 1/3. But as you may know, when you put down this, okay, P of A union B is, as a matter of fact, PA plus PB and minus A, probability A intersect B. But A intersect B is equal to empty set. Okay, it is an empty set. So then this will be 0, right? 1/6 plus 1/6 minus 0 is still 1/3. Okay? So you get it? Okay, good. So, yes, smile is good. So let us get to 159. 159, you have complement rule, okay? This is called A, right? And this symbol called, this is not A, okay? Not A. So A union not A should be equal to what? The sample space, right? Because if we draw a diagram, the whole thing is A, right? What about not A? It is outside this circle, right? These are not A. So A or not A will be equal to the sample space, okay? But we haven't discussed too much about it, so the same thing. You don't have to worry about it, but you do need to know this, okay? You do need to know this. And also P, A, union B, union C, okay? You need to know this formula, okay? You need to know these two. But you don't have to worry about this kind of complement rule. What about joint probability? Okay, 161, page 161. Joint probability means that means joint probability. We are interested in intersection. A happen and also B happens. Okay, this is called joint probability. Joint probability okay. Okay, so if you look at page 161, formula 5-4. If you look at that at the bottom, right? Formula there, okay. And there are many exercises here. 163, okay. Try your best, do some of them. If you can do all of them. 164, it talks about multiplication rule. Multiplication rule. Since in this class we haven't really talked about it, so you can forget about this part. Okay. But let us say 5-5. Okay. Formula 5-5 is set. If this is the case, okay, if this is the case, if this is true, okay, if this is true, then what's the relationship between A and B? They are, if this is true, then what's the relationship between A and B? They are independent. And also they are not mutually exclusive. That means A intersect B is not equal to empty set, right? Okay? Okay. If you look at page 166, this is conditional probability, right? This is conditional probability. And so there are rules there, formulas there, and you want to get to those. Okay? So basically, if you look at table 5-1, that's on page 167. If you look at table 5-1, that is exactly the same table I put on the board before, right? It is just that they have more items, okay? Basically, this is one good example that you can learn conditional probability, okay? Conditional probability. Okay. And then they talk about, Bayes' theorem, okay? Bayes' theorem, that's on page 171. Page 171, Bayes' theorem. So the same thing, right? They put down a formula again and tell you the idea. And then on page 171, you get the difference between two types of probability. One is prior probability, okay? And the other one is posterior probability, okay? You look at the middle part of the book, that's prior probability. And then conditional probability is actually posterior probability. You get more information, okay? You get more information. Okay. And page 175 is about formula and how to count it. Actually, you don't need to worry about it, okay? You don't need to worry about it. So I think that's about for today. But if you look at chapter 6, we already started the discussion of chapter 6, right? And actually, we already finished almost 50% of chapter 6. So the first midterm will be from chapter 1 to chapter 6. So starting next week, we will discuss some more problem sets, and also we will continue to move on to continuous random variables. So that's for today. We'll see you next week. Thank you.